Once upon a time, there was no time. No stars, no planets, no Earth, not even space itself. There was only a dot. But not an ordinary dot. This dot was so small that if you took a regular dot from the tip of your pen and chopped it into 1 trillion equal pieces, this would be one of those pieces. And inside this impossibly tiny speck slept all the energy that would become everything. Then, without warning, the dot began to grow, to stretch, to expand. After about 10 to the power of negative 43 seconds, that's 1/10 million trillion trillion trillionth of a second, the very first character of our story stepped out: gravity. Physicists also called this duration the Planck era. No longer trapped inside the dot, gravity became the force we know today, tugging on everything that ever was and ever will be. At 10 to the power of negative 35 seconds, 3 more forces escaped their tiny prison. First, the electromagnetic force, which binds molecules together. Second, the strong nuclear force, which holds the heart of every atom, its nucleus, in place. Third, the weak nuclear force, which governs radioactive decay. Now, the stage was set. At 1 trillionth of a second, the newborn universe was like a hot soup in a witch's cauldron. Photons, particles of light, were zipping around, their energy turning into pairs of matter and antimatter particles, which would meet and instantly annihilate, releasing photons again. In this boiling brew swirled quarks, bosons, and leptons. Quarks were the smallest building blocks of matter with strange fractional charges that always come in groups, and a bizarre rule. The harder one tried to pull them apart, the stronger they clung, until they simply created a new quark to keep them company. Bosons were particles, like the photon, that carried forces between matter. Leptons were a family that included the familiar electron. It was a busy, churning chaos. The soup was full of matter and antimatter, quarks and antiquarks, electrons and positrons, neutrinos and antineutrinos. And then, at just 1 billionth of a second, something miraculous happened. Matter slightly outnumbered antimatter, just by the tiniest imbalance. This asymmetry was everything. Without it, every particle would have met its opposite and vanished into light, leaving a universe with no stars, no planets, no us. As the universe cooled below 1 trillion degrees Kelvin and grew larger than our solar system, quarks began pairing up into heavier particles, hadrons. From hadrons emerged protons and neutrons, the seeds of all atomic nuclei. We've even recreated these conditions here on Earth, inside the Large Hadron Collider. Thanks to that early imbalance, some hadrons survived and went on to form every bit of matter we see today. 1 second after the beginning, the universe was already several light years big. Protons and neutrons fused into the first atomic nuclei, creating hydrogen, which formed about 90% of the universe, helium, which formed about 10%, and tiny traces of deuterium, tritium, and lithium. 2 minutes in, the recipe for the universe's chemistry was written. For the next 380,000 years, electrons roamed free, bouncing off photons like restless bees in a glass jar. Only when the temperature fell below 3,000 Kelvin did the electrons finally settle down and join the nuclei, forming the very first atoms. For 1 billion years, the universe expanded and cooled. Gravity pulled matter into great clouds, which became galaxies. Inside them, stars ignited through thermonuclear fusion, forging heavier elements. Sometimes they exploded as supernovae, scattering those elements far and wide. After 9 billion years of such cosmic recycling, our sun was born, and around it formed planets, asteroids, and comets, the entire solar system. On one small, rocky planet, positioned just the right distance from the sun for oceans to neither boil nor freeze, chemistry went to work. In these oceans, simple molecules started making copies of themselves and became the first anaerobic bacteria. These bacteria didn't need oxygen, but they produced it as waste. That waste became the atmosphere's oxygen. Some of it even formed ozone molecules, creating a shield against the sun's harmful radiation. This opened the door for aerobic organisms, life that breathes oxygen. Life evolved into strange and wonderful forms, including the mighty dinosaurs. But 65 million years ago, a 10 trillion-ton asteroid struck Earth, wiping out over 70% of species. In the space left behind, mammals flourished, and among them, a clever, curious species emerged: Homo sapiens. And so, we, You, me, and everyone we've ever known can trace our atoms back to that hot, glowing soup in the first moments after the Big Bang. We are stardust, shaped by gravity, forged in stars, refined by time, and lucky enough to tell the tale. The greatest story ever told isn't just written in books, it's written in us. Thanks for watching! That was the greatest story ever told from Neil deGrasse Tyson's Astrophysics for People in a Hurry. If you enjoyed it, hit like, subscribe, and stick around for more big reads that spark big ideas. See you next time!